In Australia, more than 85% of homes are located within 50 kilometres of the sea, with population density of 2,700 persons per square metre. So the Bayside beaches in Melbourne are an important location to look at the effects of climate change and erosion. This report studied two such locations, namely Brighton and the Red Bluff, and both have environmental geological relevance to the local area. The geology is categorised as the Brighton group, and the bedrock is called the Beaumaris sandstone, a hard ferruginous sedimentary rock laid down during the early Pliocene and later overlain by the Red Bluff sands. The Red Bluff cliffs are the type locality for this geology and represent an important reference site. Google Earth Pro was used to evaluate cliff movement and erosion of both sites. Faulkner Beacon wind speed data was used to look at the frequency of high winds. Field work was undertaken at plots in both areas to assess the vegetation cover and the hardness of the bedrock, as well as the degree to which the edge of the cliffs may be likely to fall seaward. The satellite imagery showed that the Red Bluff cliffs are continually changing, eroding and depositing this sediment seaward. Brighton Beach has undergone considerable erosion through the loss of sand and the exposure of the bedrock that was not viewable in 2009, and is disconnected from its dune replenishment system. The wind speeds at Faulkner Beacon have increased in frequency and variability in the last 20 years, especially the peak highs. The Red Bluff is also disconnected from replenishment by the walkway and lookout, and the hardness testing of the bedrock showed they are highly vulnerable to weathering, particularly at Red Bluff cliffs. Currently, there does not seem to be specific mitigation actions in place, except for building more seawalls to protect against future storm surges. However, this report found articles demonstrating that hard structures don't help bays and beaches. But there are alternatives. One is living shoreline structures. These are systems of marine vegetation combined with harder, naturally occurring structures such as oyster reefs or rock seals, designed to absorb the impact of severe weather, and microbial-induced carbonate precipitation, which is a technique that uses microbes to bind soil or rock particles together and improves their resistance to weathering. This could be particularly effective at Red Bluff. This study has been able to show examples of erosion in the past 20 years at both sites. Concerning are the predictions of increased winds and storm severity likely to come with expected climate change. Hard structures are considered to have a negative effect, and the Council is probably going to build more. However, there are alternatives that could perform better and have longer lasting positive effects. Thank you.